Okay, good afternoon, everyone, and welcome to our 2021 training series of webinars. I'm Shirley Lamb, and I coordinate the National Building Control Office training. We work with building control authorities, owners, designers, builders, and suppliers of construction products to promote compliance with the building regulations. Product suppliers have a vested interest also in ensuring that their products are used correctly in the construction process and not damaged. And where we find damaged or misused products during our site visits, we are now informing suppliers and manufacturers of these products, who in turn are encouraged to promote compliance. The mission of the National Building Control Office is to promote a culture of compliance with the building regulations in an industry marked by rapid changes in technology and processes. We do this through 5 pillars: compliance support, education and training, which is what we are doing today, inspections, our BCMS system on localgov.ie, and market surveillance of construction products. The building control legislation framework within which we work includes the Building Control Acts 1990 to 2014, the Building Control Regulations, the Building Regulations Parts A to M, the European Union Construction Products Regulations and associated market surveillance, and the European Union Energy Performance in Building Regulations. To promote compliance with the building regulations, we support building control officers in the 31 local authorities who are continually inspecting for compliance with the building regulations and building control regulations. Inquiries can be made to the relevant building control authorities or ourselves here at support@nbco.gov.ie or to the department at buildingstandards@housing.gov.ie. I would ask that you use the Q&A function throughout the webinar. The Q&A will then be provided under the video description or the comment section of the video on our YouTube channel, NBCO DCC. I will now hand you over to Diarmuid Keaney of ICANN Acoustics, who will speak on Part A of the building regulations. Thank you.
That's great. Thank you for that, Shirley. Indeed, I'll just share my screen with you now. Bear with me 1 second. Okay, you should be on your screen now, Shirley, is it? Or
yeah, it's there.
Yeah, that's great. Okay, so look, firstly, I'd like to thank the National Building Control Office, effectively, I suppose, Shirley Lamb, Mairead Phelan and Éanna O'Connell for organising today's presentation. The title of the presentation today is Sound Insulation Testing and Interpreting the Requirements of Technical Guidance Document E 2014. Just a little bit of housekeeping and a disclaimer. We just asked that all participants would keep their microphones muted throughout the presentation. The presentation will take circa 45 minutes with the questions and answers session at the end, time permitting. The presentation essentially today is designed to be informative, and it's not an alternative to Technical Guidance Document E. So I suppose Technical Guidance Document E remains the overriding document to be consulted in all cases. Also, as Shirley quite rightly pointed out, in terms of your building control officers, always consult with your building control officer or your appointed professional if there's any uncertainty about any elements within Technical Guidance Document E 2014. Okay, so an introduction. My own name is Diarmuid Keaney. My company is ICANN Acoustics. We're located at acoustics.ie. I hold an MSc in Applied Acoustics from the University of Derby, as well as that a diploma in Acoustics and Noise Control from the University of Ulster, and a BE from NUI. I'm a member and chair of the Association of Acoustic Consultants of Ireland and the Institute of Acoustics in the UK. Some of our clients throughout Ireland, it's an old list at this point, but just some of the people we work with in various elements relating to acoustics and sound insulation testing and so on. Okay, so I'm just going to present to you two slides that set out a framework to be used in terms of the application of Technical Guidance Document E. There's quite a lot in those slides, and I wouldn't expect to go through them and read them all, every single element within them, but just some key points. E1 relates to sound, and obviously, the testing of walls and floors and separating elements between dwellings. The part E2 in 2014 Technical Guidance Document E deals with reverberation. And again, this relates to common areas, internal areas within buildings. And obviously E3 then deals with definitions. Now, I'm not going to go into them in any huge detail. This slide has an awful lot of information on it, but I just want to give you this slide because I think it'll be important. This session is going to be recorded and it'll be there for you to reference. Again, we're dealing specifically with Technical Guidance Document E 2014. There was some previous editions of that, which was 1997, which was reprinted in 2005. And obviously prior to that, there was a 1991 Technical Guidance Document E. Again, this is another slide, a lot of information in it. I'm not going to go through it in any huge detail, but it just sets out the framework in relation to the building regulations and the applications of them. And I just included there so that it's in the video as well. Okay, so Technical Guidance Document E, or the Irish Building Regulations, TGD E 2014, on-site testing. And this is what I'm going to talk to you about today. So generally, in scenarios where we're dealing with semi-detached dwellings or indeed terrace dwelling, we're looking at horizontal tests. Now, if you look at that picture on screen at the moment, we say one semi-detached dwelling on the left and one on the right. So we're interested in sound transfer across the party wall or the separating elements of that property, both at ground floor level and at first floor level. And in theory, if the attic was converted, you would be looking at potentially sound transfer issues in that attic space as well. But just for now, let's deal with just the ground floor and first floor. When it comes to apartments, then we're obviously interested in horizontal performance or horizontal sound insulation tests, but we're also interested in vertical elements. If you look at that arrow I have on screen, we're interested in sound transfer between, we'll say, this apartment here, the one directly above it, or vice versa, sound transfer, airborne sound transfer from this apartment to the one below. We're also interested in impact noise and the transfer of that via floor. So again, just to keep in mind, with semi-detached dwellings and terraced houses, we're generally looking at horizontal tests, but with apartments, we're looking at both vertical tests and horizontal tests. So we're interested really in evaluating the sound insulation performance between apartments, either horizontally or indeed vertically. So you can see straight away there from those few arrows, those 4 arrows I have there, that when it comes to apartments, we're interested in sound transfer in more directions than just the horizontal direction, if that makes sense. Then when it comes to duplex arrangements, obviously we're interested in this separating element between, we'll say, the property on the left of that line and the property on the right of that line. But what is important with duplex elements is that the ground floor is also a residential unit, and we're also interested in sound transfer vertically in that particular arrangement as well, and indeed horizontally. Between, we'll say, this dwelling here and the adjacent one as well. So I just put in arrows just to show you, obviously we'll be concerned about airborne noise and impact noise, which I'll get to in a little bit, a few slides on. But again, we're interested in the separating element between those two dwellings. And again, same would apply. We're interested horizontally in the separating element between these two dwellings and so on. So just to understand that in terms of the different types of properties that are tested, you can have, as I say, semi-detached, you can have terraced, you can have duplex, or you can have apartment arrangements, and there's different testing protocols for all of those different types of buildings. Okay, so there's 2 types of tests. There's airborne tests and impact noise tests. Now, just to explain airborne noise tests, and these are carried out on walls and floors. So airborne noise, just as an example of airborne noise, if you're in a residential property and you can hear voices from an adjacent property, or you can hear the TV or the hi-fi or shouting or singing or loud speech and so on, that's an example of airborne noise. Now, keep in mind the building regulations in the UK were originally where they originally sort of stemmed from, were there really to protect people against loud speech. But just to give you a little bit of context about where they sort of emanated from originally. Now, keep in mind, in terms of the level of transfer or the sound transfer between two adjacent dwellings, the building regulations, the concept of having obviously soundproof is quite difficult, and perhaps you wouldn't do it with a semi-detached dwelling or indeed an apartment building if you did require a very, very high level of sound insulation. So again, just that might help in terms of understanding the context and where they emanated from as well in the UK. The other type of noise transfer then we're looking at are impact noise tests, and these are carried out on floors. Some examples of those, if you're ever in an apartment building and you hear footfall from the floor upstairs, or indeed footfall in corridor areas, you can have impacts on floors. Somebody dropping a jar in an apartment, for example, on a hard floor surface, it induces vibration into the structure and it'll carry through the structure. Another example of that is the dragging of chairs, being able to hear that in the apartment directly below, and even in adjacent apartments, you can sometimes hear that because of the fact that they're all sort of structurally connected, if that makes sense. This is a diagram taken directly from Technical Guidance Document E, and it's useful. It's similar in terms of what I showed you earlier in terms of the picture. You can see, for example, they're concerned about any dwelling and the separating element between that and an adjoining dwelling. Now you can see there's a little circle with A for airborne noise test, or airborne sound insulation, and I for impact sound insulation. So you can see, for example, I'll just show you with the mouse, you have any dwelling and there's concerns about airborne transfer vertically and indeed impact noise transfer vertically. And the other thing I should point out is that there's also in most cases concern then about obviously transfer between the dwelling and any other parts of the same building. So again, that diagram is useful in terms of, I suppose, understanding the requirements in terms of both airborne noise and impact noise as well. Okay, so the measurement kit. So when we're carrying out a sound insulation test, what do we use? Well, for airborne sound tests, we use a speaker called a dodecahedron speaker. It's basically an omnidirectional speaker that generates, with an amplifier, generates pink noise and fills a room with pink noise. It's essentially a test signal that we use to carry out a sound insulation test. We also use an analyzer or a handheld sound level meter with a software on it to deal with sound insulation tests specifically. And indeed, we have an amplifier and signal generator to run the dodecahedron speaker. When it comes then to impact noise, we use a device called a tapping machine. And this is essentially a device that's placed on the floor of an apartment and where it runs and it generates impact noise or induces impact noise into a floor. And I'll deal with that in a little bit more detail in the next couple of slides as well. So let's just look at an airborne sound insulation test. These are, you're essentially looking at two dwellings side by side. That split line you see down the center is the separating element between those two apartments. And if you look in through the window there, I've set up our dodecahedron speaker on a stand. And obviously what I want to highlight here is that always there is a source room involved and there is a receiving room. So as part of the tests across a party wall or indeed a separating element, you're dealing with a source room always and a receiving room. So in terms of the sound insulation and sound transfer between those two rooms, It's important to realize that you're dealing with direct paths, and that's sound that travels directly through the wall. Now, keep in mind, direct paths are only one element of the sound insulation test. The sound insulation test is a room-to-room test. So it measures both direct paths and indirect paths. So you need to keep in mind that even when you generate noise in the source room, you'll obviously have a certain amount of noise that'll break through the separating element, but you'll have noise that'll flank over the separating element, under the separating element, and around the separating element. So keep in mind, it's a room-to-room test, and it consists, the performance is made up of direct paths and multiple indirect paths. So it's the junctions as well as the wall itself. And you'll notice technical guidance document E 2014 is very good on that, and it's very strong on that in terms of it defines the wall buildup, and indeed there's a lot of attention paid in relation to the junction detail, because it is realized the importance of the junctions, and in terms of the flanking, they're called flanking paths, and how sound travels both through the separating element and around the separating element. Then when it comes to apartments, it's the same situation. When you're carrying out a sound insulation test in an apartment, again, you're dealing with a source room. And if we take this sample here as being a source room, and again, above it, we'll say receiving room. So you can test in that direction or vice versa. Again, there's protocols about the direction of test and so on, which I won't have time to go into in this particular presentation, but just keep in mind, you're always dealing with a source room and a receiving room. And again, with that, you're concerned about, we'll say, for example, in terms of an airborne test in this direction, you're concerned about transfer via the floor slab, but you're also concerned about, you should be concerned about flanking paths, sound that travels around the floor or through. For example, if you look at this curtain wall detail, again, when you carry out a sound insulation test between those two rooms, there will be direct paths and there will be indirect paths. So that's paths that will flank around the actual floor element as well. So you can just see in a situation like this, the importance of that junction detail would be critical. Now, that's not a junction detail in technical guidance document E, I should point out as well. But just the reason I use that sample really is just to show you that the junctions are as important as the separating element. So they should be considered very carefully. Now, not only in apartments, then you're concerned about obviously vertical transfer, but you should be concerned about horizontal transfer as well. So suppose this is that source room is one apartment. You may have an adjacent apartment over here. I'm showing you with the mouse, if you can see that on screen. So again, you need to be concerned about horizontal transfer and the junction detail there as well. Now, again, as I said to you, this detail is not in technical guidance document E, but I think it's a good one to illustrate flanking paths and the potential weaknesses caused by them. Okay, so again, always think there are direct paths and multiple flanking paths. In terms of impact sound insulation then, this is the close-up example of a tapping machine, and you'll notice it's got 3 feet and it's got 5 hammers, and I'll show you in a later slide how they work. But in fact, if I open this, this is what it looks like inside. So if I go back one slide, so that's it with the cover on. If I take the cover off, you can see that there are 5 hammers. They're half a kg each. They're inside in the tapping machine, and what happens is we place the tapping machine on the floor of an apartment at a certain location, and the hammers fall at a certain height. And I'm just going to play the video here just to show you how that works. So that the hammers strike, this is it in slow motion, the hammers strike the tiled surface. Okay, so you can see that they strike it repetitively. And the idea is that this tapping machine becomes a standardized source that we use to carry out impact sound insulation tests. I'll just run the video again there. So it obviously happens a lot faster than what you're seeing on screen right now, but the reason I've slowed it down is I just want to show you what happens. So if you can imagine, each time one of those hammers strikes the tile, it induces noise or indeed vibration into the structure. And the thing to keep in mind is that this tapping machine is built in accordance with a specific standard. So anyone carrying out sound insulation tests should be using a tapping machine that meets the type approvals, calibrated, and so on. And the idea being that if anyone was to carry out a sound insulation test, or another party was to go in there and repeat the test, in theory they should be getting the same results, in that the equipment should be identical in terms of its performance and how much, you know, noise or vibration it induces into the structure. So just in terms of impact noise tests, and just to explain it a little bit more. So that's the tapping machine. We place that on a floor, and what happens is the 5 hammers strike the floor and they induce noise and indeed vibration into that. It sets that floor panel into excitation, essentially. So what happens is, if you can imagine it, it induces vibration into it. Now that will also carry along the structure. And you'll notice that in most masonry buildings, for example, there's very good and efficient coupling between walls and floors and so on. So what happens is the tapping machine induces vibration into the structure, sets it into excitation. And what actually happens is those vibrating walls re-radiate that as noise. So again, we're in the receiving room. So just, and I'll come to it later, and this is important in terms of dealing with the metrics, but you can imagine if that tapping machine was off the floor, if I was to temporarily lift it off the floor, that the noise level would be a lot less. So the only reason I say that is it's important to differentiate between impact noise and airborne noise, and I'll explain that in a little bit more detail. But you can imagine, let's take this example. Suppose I was to put that tapping machine on a soft rubber mat. It would mean that the tapping machine is striking the rubber mat and not inducing as much vibration into the structure, and consequently the noise level will be a lot lower in the receiving room directly below. So just keep that in your head in terms of the metrics, because it is important when it comes to discussing the metrics in Technical Guidance Document E, which I'll do on the next slide. So the standards and the metrics used. So you'll notice within Table 1 of Technical Guidance Document E that it sets out a minimum airborne requirement for walls and floors. And you'll see it uses this metric called the DNTW, but it suggests that the minimum should be 53. Now keep in mind, if I was to carry out an airborne sound insulation test, the higher the DNTW value, the better. So essentially, if I was to carry out an airborne sound insulation test and, for example, measured 48, it wouldn't meet that minimum. Whereas if I carried out repeated an airborne sound insulation test on another property and got a value of 60 dB DNTW, it would be comfortably above that minimum value. Now, in terms of impact noise, it's the other way around. If you recall, we're looking not to exceed a maximum of 58. And if I just go back to the slide earlier, if you think about a maximum of 58 and not exceeding it, a building that has a better resistance to, or a high resistance to impact noise, will result in a lower level in the receiving room. So that's essentially why the metrics, why with airborne noise, you're looking for a value greater than those stipulated, those minimums stipulated, whereas with impact noise, you're looking for the value not to exceed 58. So for example, if you measured 59 in your room, obviously the building is very efficient in terms of carrying impact noise into the room below. So again, that's the difference between the maximum and minimum. You're looking for a maximum in terms of airborne noise and a minimum in terms of impact noise. Now keep in mind, when we'll say carrying out a sound insulation test, and which I would remind you is a room-to-room test, we're carrying them out in accordance with a specific standard. And the whole idea behind using a standard like this one here, ISO 16283 Part 1, 2014, that deals with a specific standard in relation to carrying out an airborne test. So it means that if if anyone, if somebody who's, I suppose, qualified to carry out a sound insulation test goes in to test a property and somebody else tests it 6 months down the line, in theory, once they're following the standard, they should get repeatable and consistent results. So it's very important that all the tests are carried out in accordance with the standard. So there is a specific standard in relation to airborne tests, and that's it on screen. In relation to impact noise tests then, where we measure the LNTW metric, again, it's the same standard number, but it's part 2, and it was